Hello guys, welcome to Maths Minders Academy. If you are new to our channel, we urge you to hit the subscribe button if you have not done so. Click on the notification bell icon so that each time we produce a new video, you'll be among the first to receive it. Share this video, like this video. Today, we are going to look at IGCSE paper 4.1 solutions. We have done a video that covers part 1 and 2 of paper 2.1, and so we are very excited to produce another video that covers paper 4.1. So guys, the link to this paper is already in the video description. You can download it so that you will follow through the solutions. And of course, for maximum performance, we urge you to probably first do the work and then use our video to assess yourself. By so, you'll be able to get the best out of this tutorial video. So, let's move on to question number 1. Number 1 has 3 parts: I, and I. So we are going to question number 1AI. We are required to write 70 as a product of its prime factors. Write 70 as a product of its prime factors. How do we do that? So here we are going to use the tree method. And what does this tree method involve? It involves breaking 70 into parts, as multiples of prime factors. So we have 70, and then we are going to think of the smallest prime number that can divide 70, and that prime number is 2, because if we multiply 2 by 35, we get 70. Can you think of another prime number that can divide 35? A prime number possibly bigger than 2, because 2 cannot go in 35. Bigger than 2, and it can divide 35. That prime number is 5, and when we divide 35 by 5, we have 7. And again, can we divide 7 by any number bigger than 1? No. And of course, there's no other prime number that can divide 7 except 7. And so we now pick these 3 prime numbers to act as the product, as product that will result to 70. And so we write 70 as a product of these 3 prime numbers. So 70 equals 2 times 5 times 7. So we've been able to express 70 as a product of its prime factors. Prime factors because 2, 5, and 7 are also factors of 70, and they are prime numbers. We move on to the next question, and that's question number 1II. Here we are required to find the highest common factor, or the HCF, of 70 and 112. So again, we are going to look at 112. Remember, we've been able to break 70 into prime factors. We re-express 70 as product of prime factors. We are going to do so for 112. And so we think of the smallest number that can divide 112, and that smallest number should be a prime number. That number is 2. 2 times 56 is 112. Again, let's break 56 into 2 parts, such that a part will be a prime number, the smallest. And that is going to be, again, 2 times 28. That gives us 56. Can we break 28 again into 2 parts, so that one part will be a prime number? Yes, that will be 2 times 14. Again, we can break 14 into 2 parts, and that will give us 2 times 7. 7 is a prime number, 2 is a prime number. Now, of course, there's no other prime number lower than 7 that can divide 7. And so what we do now is to pick up all the prime numbers that we use to divide 112, and these are the 5. Of course, we say 5. 2 is the same all over, 2 in 4 places, and then 7. And so we line them up. You can say 112 equals 2 times 2 times 2 times 2 times 7. Again, you can write it in index form. It becomes 2 raised to power 4 times 7. And now let's bring 70. We've expressed 70 before as product of prime factors, and that gives us 2 times 5 times 7. Now we are going to do something. We are going to look at numbers that are common between the prime factors that are common in 112 and 70. We circle this, okay? We'll pick them up. These are, kind of intersection. The numbers common, they will act as the highest common factor, the product of these two numbers. So the HCF of 112 and 70 will be 2 times 7. That gives us 14. So 14 is the HCF of 70 and 112. Hope this solution is clear enough. If there is doubt, or probably you didn't get the step at the first instant, you can go back and replay the video so that you get the details. Okay, with this, we proceed to the next question, which is the question 1A I. Here, we are required to find the lowest common multiple, otherwise called the LCM of 70 s to power 4 y to power 2 and 112 s to power 3 y to power 5. So what do? We say here we will find first the LCM of the numerical coefficients. What are the numerical coefficients? 70 and 112 are the numerical coefficients. And so we are going to find the LCM of these two numerical coefficients. Okay, and so we said the LCM of 70 and 112 is obtained by taking the highest power of each prime factor. Highest power of each prime factor. Remember, we express 70 as 2 times 5 times 7, and we express 112 as 2 raised to power 4 times 7. Okay, now we are going to look at the highest power. When we pick 2, we have in 70 we have 2 to power 1, and in 112 we have 2 to power 4. Which of these has the highest index? 2 raised to power 4 has the highest index, and so we are going to pick that. And then we look at 5. In 70, 5 comes with power 1, and in 112 there is no 5. Of course, we can also claim that 5 is there but given to power 0, and of course by the law of indices, when a number is raised to power 0 is equivalent to 1. So when we compare now, the number with the highest index is 5, which appears as a factor of 70. We pick that, and then we compare the 2 7. Of course, they have the same index, 7 to power 1 in 70 and 7 to power 1 in 112. We are going to take one of them. Okay, so we line them up. 2 to power 4 times 5 times 7, and this results to 560. So guys, the LCM of 70 and 112 is 560. So we have been able to take the LCM of the numerical coefficients. All right, so we are going to look at the variable part. And so we now say, now let's find the LCM of the variable part, which are s to power 4 y to power 2 and s to power 3 y to power 5. How do we do that? Now we bring out this variable part, and we are also going to do the same thing, compare the variable part with the highest index. So when we look at the variable s, we'll bring the 560, and then we look at the variable s. In one part, we have s to power 4. The other part, we have s to power 3. When you compare this, the one with the greatest index is s to power 4. And that's the one we are going to take. So we take that, and then we are going to compare the y. When you look at the y in the two variables, we have y to power 5. And in the other part, we have y to power 2. When you compare this, you take y to power 5, it has the greater index. And so guys, 560 s to power 4, y to power 5 will give us the LCM of 70 s to power 4, y to power 2, and 112 s to power 3, y to power 5. That will be our final result. Hope this is very simple and clear. If you are enjoying this tutorial video and you are not part of our YouTube family, we urge you to hit the subscribe button right away. Click on the notification bell icon so that each time we produce a new video, you'll be among the first to receive it. Share this video, like this video, go to the comment section and tell us something about this video. We want to hear from you. Say something about this video. We are proceeding now to the next question, and that's the B part. Here we are solving BI. We have a raised to power 12 divided by a raised to power 4. We are asked to simplify. How do we simplify this? We are going to use the law of indices, and what it means is that because we are doing division and the bases are the same, the expressions have comes with base A, and so we are going to subtract the index of the second variable from the index of the first, and that's why we have 12, a raised to power 12 minus 4, and finally that will give us a raised to power 8, and that's the final simplification. We move on to the next part, that is 1bii. We are asked to simplify this algebraic fraction, and so we are going to use 5 to divide 20 first. 5 divide itself 1. When 5 goes in 20, we have 4. And then we look at BC over 2B. B is common, B is in the numerator, and B is in the denominator. So we cross out these B's, and then we multiply. We now have 1 times C, that gives us C, and we have 2 times 4, and that gives us 8. So we have 1 over 2. In the first fraction, what is left there is 1 over 2. In the second fraction, what is left is C over 4. When we multiply, we have finally C over 8. We move on to the C part of this question. Here we are asked to solve 4 plus 2s equals 15. How do we handle that? 4 plus 2s equals 15. We are going to subtract 4 from both sides. We are using balancing method. Subtract 4, which is the constant at the left hand side, from both sides of the equation, and we now have 2s equals 11, because if we subtract 4 from 15, we have 11. Of course, subtract 4 from 4, you have 0. So we have 2s equals 11. We are going to divide both sides by 2, and that gives us s equals 11 over 2. You have a choice either to leave it as decimal or to leave it as mixed number. As decimal, it will give us 5.5, or if you leave it as mixed number, which is an equivalent of 5.5, that gives us 5 whole number, 1 over 2. And we've been able to solve and got the value of s. We proceed to the D question. Here we are asked to solve this algebraic equation. 34 plus 2s over 5 equals 4 minus s. Okay, so what do? We are going to multiply both sides by 5. And if we multiply both sides by 5, the left hand side, the 5 that is acting as denominator will vanish, and the right hand side we are multiplying by 5. Okay, and when we do that, we are going to have 34 plus 2s equals, if you open the bracket at the right hand side of the equation, it will give you 5 times 4, that's 20, and 5 times minus s, that will give you minus 5s. And then we are going to collect like terms. Okay, the minus 5 crossing over the equality sign to the left will give us plus 5. So we have to the left side of the equation 2s plus 5, and to the right side of the equation, when we collect we cross over 34 from left to right, we have minus 34. So we have 20 minus 34. And then adding up, we have 7s equals to minus 14. We are going to divide both sides by 7. And that gives us minus 14 over 7. And here, the value of s is minus 2. We are very confident that this solution is explained in a simple way and that you understand it. You also can replay this video over and over until you get this very concept. Now, we are moving on to E. Here, what are we asked to do? For E, we are to substitute. We are given P equals D plus the cube root of M squared, and we are asked to find P, that is the numerical value of P when D is 7 and M equals minus 8. That's what we want to do here. And so we line up the values given and we are going to key them into the formula there. So P becomes 7. 7 is the value of D plus the cube root of, in bracket, minus 8, which is the value of M. Then we raise that to power 2. And of course, if you raise minus 8 to power 2, you get 64. Bear in mind that when a negative number is raised to an even value, you obtain a positive number. And also, it's important you use bracket to enclose this negative number. And so we are now going to take the cube root of 64. Your calculator can be handy, or you think of a number you can multiply 3 times to get 64. That number is 4. 4 times 4, 16 times 4, 64. So the cube root of 64 is 4. And we are now adding 7 and 4 together. That gives us 11. So, guys, the value of P in this equation given, or in this formula given, when we substitute other variables, value of other variables, we'll get 11. Okay, we move on now to EII to rearrange the formula in order to make M the subject. And so this is the formula given to us. Initially, P equals D plus the cube root of M squared. And so we want to make M the subject of the formula. What do? We are going to move D to the left, and that will give us P minus D equals cube root of M squared. And then we'll be thinking, we just want M to stand out. What else can we do? What do we do to remove cube root? Of course, we are going to use cube to remove cube root. So we say take cube of both sides. That's what we can do to remove cube root. And so when we take cube of both sides, the cube and the cube root will cancel out, because of course one is inverse of the other, so they'll cancel out, and we have M squared equals P minus D raised to power 3. You don't need to bother opening the bracket. Remember, we are looking for M in terms of the other variables P and D, so we want to make M the subject. So we'll be thinking, how do we remove the power 2 attached to M? We are going to use square root to remove that. So we say take square root of both sides. And when we take square root of both sides, M becomes plus or minus square root of, in bracket, P minus D, all raised to power 3. This will be the expression we'll get when we rearrange and make M the subject. We move on now to question 2. If you are yet to subscribe, or you're just joining us and you have not subscribed to our channel, you want to support what we are doing, producing educational videos that will help students to prepare their examinations with ease. If you want to support us, why not subscribe, give us a thumb up, like, share this video, go to the comment section and say something about this video. We want to engage you with discussion to see how best we can make more videos. And so question number 2, we are told that on the grid, draw the image of triangle A after a reflection in the line S equals 1. So what do we do first? We are going to draw the line S equals 1. Okay, that's that line, vertical line passing through the point where S equals 1. Okay, now we are going to look at the object, that's triangle A. The distance of the vertex, one of the vertices of this triangle, the vertex that is not attached to the red line, the distance of that vertex to the red line is 4 bosses. Okay, that means if we want to reflect that part of the triangle, that is shifted away from the red line, if we want to translate it, that means we are going to take 4 steps away, moving forward. After the red line, we are going to count 4 bosses to be able to reflect that. And so we count 4 bosses, okay? And when we're done with that, we mark it, okay? And so we take another point, the points that are the vertices of the triangle that are attached to the red line have 0 distance away from the line. Okay, and so their image will also have 0 distance away from the line going forward. I'll say also the image and the image point and the object point for those 2 vertices that are on the red line will coincide. Okay, after reflection, so the image point will become the object point will also become the image point. Both will lie on that red line. Okay, and so we now draw the complete triangle to show the final reflection. And so this is what we get. Again, what are the vertices of this image? We need to write out the vertices of the image, or the coordinate of this image. And so we have these 3 points, 1, minus 1, 1, minus 3, minus 3, minus 3. These are the 3 points after reflection. These will be our new images.
For question number 2A, we are told that on the grid, draw the image of triangle A after an enlargement by scale factor half with center 5, 1. So we are going to first of all identify the center. That's where the coordinate 5, 1 is positioned on our SY plane. So we can see that center. And now from the center, we are going to run 3 lines to pass through the 3 vertices of the triangle. And so we have these lines running through the 3 vertices of the triangle. So to enlarge, we are going to enlarge point by point. We take the first point, the point we marked with blue. And so we are going to look at the distance of this point from the center of enlargement. The distance of this point from the center of enlargement. How do we calculate the distance? We run a horizontal line from the center of enlargement, and we run a vertical line from where the horizontal line stops down to where we have the blue point. So from the vertical, from the center, we have 4 bosses running horizontally, and then we have 2 bosses running vertically. So we can put this in the form of a column vector, and that gives us the component 4 for the S, and for the Y component we have 2. We multiply this by the scale factor 1/2. That is 4 times 1/2, that will give us 2, and 2 times 1/2 will give us 1. So we have a new vector that represents the enlarged point by the scale factor half, and that vector has component 2 for the s and 1 for the y. And so what are we going to do with this new vector? It means again that the image will have a distance 2, that is 2 buses from the center running horizontally, and 1 bus running vertically. So we take these 2 buses from the center horizontally, and we take 1 bus vertically, and that gives us the image of that first vertex of the triangle. We proceed again to look at another point. The second point, we want to also find the distance from the center of enlargement. So we look at the horizontal distance is 4 buses away, and the vertical distance is also 4 buses away. So put this as a column vector and multiply by the scale factor half. The column vector with component 4 for the s value and 4 for the y value. If we multiply 4 by half, we get 2. For the s value, the component for the s value is 2, and for the y is also 2. What that means is that from the center of enlargement, we are going to take 2 buses horizontally, and then we are also going to take 2 buses vertically down. We get the image of the second vertex. We get the image of the second vertex. So we look at the third vertex of the triangle, and the distance from the center. All right, we have coming from that center down to where the third vertex of the triangle is, we have 4 buses down. There's no horizontal movement. Okay, and then if we multiply this 4 by half, that gives us 2. So we have from the center, we take 2 buses down to get to the middle where that green point is. That will give us the enlarged image, or the image after the enlargement. And so now, after we are done with this, we now put the triangle. We use the line, connect the 3 points to give us our triangle. Okay, and so we look at the coordinate of the image. That's this new triangle that we produce, which is the image of triangle A. What are the coordinates? 3, 0, 3, -1, and 5, -1. Hope this explanation is clear enough. You can replay this video until you fully understand this concept.
Okay, let's move on now to question 2b. Here we are asked to describe fully the single transformation that maps triangle A onto triangle B. Okay, the single transformation. Remember that in Cambridge IGCSE examination, especially for students writing 0580, in your syllabus under transformation, you have these 4 transformations to be tested upon. The first is enlargement, we have reflection, we have translation, and rotation. And so now we are asked to describe fully the single transformation that maps triangle A onto triangle B. Can it be enlargement? Of course, it can be enlargement, and the reason is because both the object and the image have the same shape, the same size. There is no, because enlargement is meant to either bring about an object that is an image that is smaller than the object, or an image that is bigger than the object. That's the work of enlargement. It becomes smaller when the scale factor is less than 1, and it becomes bigger when the scale factor is greater than 1. But if you look at shape A and shape B, they are of the same size. Just that one is turned over. So it is not enlargement. So we are going to cross out enlargement. We ask again, can it be reflection? It cannot be reflection because reflection results into flipping over. When we look at this does not look at what is flipped over. And another thing that we can use to test for reflection is you can use a line to connect the three vertices. If the lines that you obtain are parallel, you know that is reflection. But if these lines are not parallel, then it cannot be reflection. Remember again that one of the key property of reflection is that it flip over the object to obtain the image. But what we have here, when we look at shape A, triangle A, or look at triangle B, it's not a flipping over, it's a turning over. So it is not reflection. So we cross out reflection. Can it be translation? No. Translation will result into a sliding or gliding movement, either upward, downward, forward, or backward. Okay? And it does not flip over, it does not turn over. But if you look at shape A, if we shift shape A back, we cannot get B. Okay? Even if we shift it back and shift it up, we can see that the B has been turned over. And so translation does not turn object over to get image. Is going to result into a gliding or sliding movement to produce the image. And so this is not translation. So we cross out translation. Is it going to be rotation? Definitely. It's going to be rotation because this has been turned over. This has been turned over. So since it's rotation, what are we going to do? We are going to try to find out where the center of rotation is. There are two ways. It's either you use the bisection method or you use tracing paper. But here I'm going to introduce the bisection method, which tend to give a more accurate result. So I'll connect 2 points, two corresponding points, one from the object to the image. I will use a line to connect it. Now, these 2 points, okay, I want to find the center of this line segment from one point to the other. Of course, if you understand geometry very well, you know that what I will do here is to take the S value of the 2 points, add and divide by 2, just to get the midpoint of these 2 points. The S value of the first point is -3, and the S value of the second point is 1. So I will take -3 plus 1 over 2. The Y value of the first point is 5, and the Y value of the second point is -1. I will add and divide by 2, just like it's displayed on your screen. And that will give me the center, which is -1, 2. It will give me this, not the center of rotation, but it's going to give me the center of this red line. I need that center because I'm going to bisect the red line, and that's why I need the center. Okay, and so I mark the center. I'm teaching bisection method now. Again, I will use my protractor to be able to get the second point. I'll put my protractor on that line and ensure that it lines up with 90 degrees. Okay, so I put the second point exactly on that point where the 90 degree is. Okay, and then I'm going to carefully draw a line to pass through. All right, so I have been able to bisect this red line. Now I need a second line. I need a second line. So I will connect again another corresponding vertex from the object to the image, corresponding vertices. So I'll use a line to connect it. I'm going to do the same thing again. Of course, look at the S values of these 2 points, -5 and 5. You add and divide by 2. You do the same thing for the Y values, add and divide by 2. You'll be able to get the middle of this line, and then you now put your line to pass through. Of course, you don't need protractor again since you already have identified the other point, okay? So you just carefully run the line to pass through the middle of this second line that connects the vertices of the object and the image, and then ensure that it passes through that center there. Okay, now when that happens, we've been able to get the center of rotation. We are going to do something to get the angle, all right? Because we need, for rotation, we need the name, we need the angle. Of course, the direction is also important, and we need the center. So here we see that for us to get the angle, we take a line from the object point to the image point, to the corresponding image point. The broken line, the red broken line, move from the object point to the corresponding image point, and the angle formed there is 90 degrees. And you know, if you are moving from the object point, that is from triangle A to triangle B, you are going clockwise. So it's going to give us 90 degree clockwise. So let us write down our answers. And so we have rotation, we have 90 degree clockwise, and then let's take the center. We have our center 2, 4, and that completes what we are asked to describe. Single transformation that maps triangle A onto triangle B. Please replay this until you fully understand this concept. All right? It was for all transformations. Of course, you can also try out the use of tracing paper. It's either you use the bisection method or use the tracing paper, trying out points around the neighborhood of this, of the object and the image. Let's proceed to the next question. For the C part, we are told that the point A, B is reflected in the line y equals k, where k is an integer and b is less than k. Write the coordinate of the image of point A, B in terms of A, B, and K. Okay, so now how do we do this? We draw a line, okay, the line that we call y equals K as required, and we mark a point, just an arbitrary point, okay, and that point will represent A, B, all right. And remember that K and B is below K, because we are given a condition that B is less than K. We are K is an integer, a whole number. So we put B below that line to show that B is less than K. And now we are going to find the distance of that point to the line. Of course, the distance is going to be K minus B. Just like you have it, if you want to find the distance and you have y equals 3, at that point, at the point where we have A, B, the value of B will be 1. If you want to find that distance, it's going to be 3 minus 1, which is 2. So the distance is actually K minus B. And now we reflect. How do we reflect? We take that, it means that the red point, if it is reflected, using the green line, that's the line y equals k as our mirror line, then it's going to be reflected over by the same distance. And so we take the reflected point above. And now, but how do we ensure that that same distance is what is given? It means that here we are going to have k, okay, plus that distance. Remember, just like we have 3, if the distance is 2, 3 plus 2 will give us 5, which is where that second red point is. So it's going to be k plus the distance, which is k minus b. And so we line this up to see what our answer will look like. If we look at it, the A, which is the S value of that point, does not change. It remains A, but the Y value when that point is reflected move from B to K plus K minus B. And when you open the bracket, k plus k minus b becomes 2k minus b. So the new coordinate of the image will be a, 2k minus b. All right, this is where we end today's tutorial video. We thank you very much for your endurance. If you have been with us from the beginning till now, we appreciate you. Next time we'll continue from question number 3. Look forward to the next video, the next part 2, where we'll be discussing solution to question number 3 and other questions thereafter. If you are yet to subscribe, you are joining us, this is your first time, or you've been following our video but you've not subscribed, we urge you to smash the subscribe button, hit the notification bell icon so that each time we produce a new video, you'll be among the first to receive it. Like this video, share this video, give us a thumb up, go to the comment section, tell us what you feel about this video. This will help the YouTube algorithm to send this video to as many students as possible. We want to reach out to all students so that our video will be our own way of helping students to prepare for examination. See you in our next tutorial class. This is Math Minders Academy saying goodbye for now.